Continuous stupidities, myths of DevOps. Myself, I'm working as a consultant mostly in huge Java web applications with teams about more than 10 developers, often more, much more. I have now since around 20 years experience in the configuration management topic. Today we call this DevOps. Since a short time, I give my knowledge also as a trainer in courses. You can find some articles in German magazines, and even I had wrote a book, Continuous Integration with Jenkins. So there is kind of experience we could talk about. What we are going through today. As first, yes, of course, we have to discuss a bit what that means, DevOps. In this way, there is so many mismatched definitions we have to keep an eye on, and we should think about it, how we use the words, because often the way we are talking, we are thinking. Sometimes it's getting a bit more complex, and we could reduce complexity if we are thinking a bit more about the words we're using in the topic of DevOps. And of course, with this knowledge, we can through the paradigms on how we could implement them for us in a very efficient way. Of course, there are some reasons how to manage your own processes, how to find a transformation that everything goes fine. And the last point, of course, we are talking about what we do in the worst case when something goes wrong. With this, we could start. But first, a short word on the slides of this talk. I will publish later after this on my homepage, alma-com. There you can find, even if the video is once available, I will link the video there too. Development and operations, the artificial world, DevOps. And this is another view of the software development lifecycle. Here we see there is plenty of phases we have to pass through until your application is usable for the final customers. There's involved a lot of roles. Often I have the problem when I join teams, they have the idea, a DevOps engineer is an all-including person. Definitely not. Is not like this. We have several roles because a developer knows how to create an application, and an operator or administrator knows how to run an application and how to make secure the servers and everything around. And exactly, these are completely different tasks and knowledges. If a developer tries to run an application in a secure state, well, he will fail. And the same operator or administrator will fail if he is trying to implement something in an application. In this way, we have to think about there is so many other resources, or not just resources, also other persons they are involved. No? The planning also is not done by a developer. There's mostly involved something of the management and business analysts. The other thing is, of course, after development, there is a testing engineer mostly involved in huge systems or in huge projects. So we should not have the basic idea, okay, we have an all-in-one person. So there are borders, and we need these borders too. Even there is a giant border between DevOps and operations. Now, for security reasons too, you will not find any bank, insurance company, or something where a developer have access to operations. It's almost impossible now, because we have to secure that the running data of the clients using the application are secure. So the access is very limited. And we see that also if you are needed to fix a problem and you're asking for log files from production, there is, in the most biggest companies there, in general, in companies, there is a process how to anonymize data from operations. So this shows you, develop and operation, they are two different things. The biggest important thing about what we are doing here is we are in an agile culture. DevOps is a culture we have to implement in our business unit or in our organization. And that means we have to tear down information silos. And when we are talking about tear down information silos, that means when I'm creating, for example, my build logic, I will do that as a developer. And if I want to develop some delivery pipelines on installments on some stages, so I will always ask there a guy of operation because they have the knowledge how to do that in a very efficient way. And then we have a process we can use for testing stage. It's almost the same like in real operations. There we get automatations. So in this way, when you try to create a DevOps team, put both roles inside, there have to be a developer and there have to be an administrator. If this is just dominated by one, it will not work. And this is what I was seeing. There was administrators trying to create build logic and doing some solutions for developer. They had to work with it. This was getting extremely worse because an administrator don't know the necessities of a infrastructure is needed by developers. The same opposite, the developer don't know what is important for deployment. So put them together, there you will get the best symbiosis. Another very, very important thing is follow standards. Don't create your own standard. Mostly this don't work. The problem is of not having or not following standard is we are running in the paradoxum of automation. And that means simply everything gets too complex. And when you reach a level of complexity, you cannot manage anymore. This we try to avoid. For that reason, I always like to cite Gardibu. He was saying something like, a fool with a tool is still a fool, because the biggest problem is if I have processes, they don't work. I will not find a tool to fix that. I have to reorganize my processes. I have to refactor them. I have to make them more simple. And then I can think about it when they are following some standards, and if they are good to automate, then I can decide what kind of tool I want to use. Because the infrastructure we already now need for software development is quite huge. A very, very important topic I always discovered in almost every project is test automation. If you're running in DevOps, if you want to do something with the name continuous something, and you don't have any test automation, you're far away from what it means continuous. Sometimes companies, they have some tests they can run automatically. They think, they are in a secure state, but they was not following some standards, and you really have to go test driven. What that means is when a developer is implementing some things and he's coming and do his task, and then he's trying to spread around some system out statements and somehow integrate this in a UI to see how his implementation is working, is not testing. I mean, is a manual testing, but in the case there is some issues, how you can repeat the test is not working. So in that way, try to write atomic unit tests, and this helps you a lot. And if you have to connect other systems like a database to see if your GPA statement or SQL statement, if this is working, then you have an integration test or component test. You can use it, or even have you tools like Maven or Gradle, separate them and say, okay, everything don't need any connection to a database or file system will be unit tests, and other things they need a connection, they will be integration tests. For this we have this dividing. And this, what the most people are thinking of integration tests, they will use other techniques. For this we have test engineers. This will be behavior driven. There is tools like Cucumber and Given and so many other things we have to implement to have their automated test strategy. So the words always are mismatched between and have so many meanings, and for that reason we have to think about it. Now there is no no completely best way, no the almost happy path. No, we always have to see what is the necessity of our project and how we can fit the project into standards and not the standards to the project. This is very important. And for that, we have some definitions. I really try to advocate to use these words, release, deploy, and deliver, a bit more carefully. If you're checking out their Merriam-Webster, we have for the word release two definitions. As first means giving up in favor of another. And this is very clear. When we leave the implementation phase to move in a testing phase and then later installing deployments and so on, yeah, this could be a release. So finally, the sprint is over, moving to testing, we have a release. Another definition is, of course, make available to the public. And this fits the same because finally, we create a binary and we hand it over to the next division, testing, for example. That means release, we should more use the word package. We create a binary somehow, or we package some scripts together, and then we have the release. And something equal is with deploy. I really recommend to use more the word storage, because finally what we are doing is we have our binary artifact and we have to store somewhere for reuse. The store could be a repository manager like Nexus, Artifactory, or other commercial tools that are available. And then we have exactly spread out, utilized, or arranged for deliberate purpose. Exactly, this is what we need. We don't always, when we are going into testing, a test engineer is not in a way to come check out the project source code, compile this, try to fit his test code with Cucumber or something around. No, he's taking the binary and include the binary in his own project. And for that, we have this cycle of package and storage. And deliver, of course, is installing. Finally, because we have to install somehow our system somewhere. Testing in the final stage, then of course in production. And finally, deliver is more something like, yeah, bring the application into an environment. And when we have clear these three words in the order of package, storage, and install, we can create much more easier processes. So many things get more easy because we don't have to think about so many things. In this way, I want to remind in the thoughts of Paul M. Duval he was doing in his book Continuous Integration about what is continuous. And continuous is not a perpetuum mobile. No? You start and then just continue. No, we have something we can start when we need it, and then it's run through. The best effect of this continual is we can start it very, very often when we need it, not always because we can do. And these are things where we jump into paradigms. Continuous integration, a lot of people there put everything in the word continuous integration, but finally, this is something more simple. You have to go back some decades before, around the change of the millennium. There was a book written by Andy Hunt. He was describing in pragmatic project automation, the pragmatic developer, something about a build machine. Because what we have here is a commit stage. And what is the commit stage? Source control management. That means we have something like Git or other tools around. And when there is a branch of developers, they're working together on the same code base. We have to secure that the code base is always in a buildable state. We have to compile that. And this is what continuous integration finally is doing. There is a finally build server checking out the source code almost after every commit and check if the source code is still compilable. Because I was observing when I was new in the industry, there was some commits. a developer forgot to commit a file or something, and they break down the build. With this, yeah, their 5 or 10 developers was not able to work for 1 or 2 hours until everything get fixed. And this was the time of subversion. You was not able to switch back to another revision without losing your changes. No, this was very difficult. And for this, continuous integration developed finally. And today we use it a bit more wider. We are including there executing the unit tests. This you can see when you use in your project something like Maven or Gradle. No, you have their own steps in a build: compile, test, and package. And when this is going through, everything is fine. And in a continuous integration environment, we are not talking about put all the components together in a whole application. This is another step. There we are into continuous delivery. When we have the continuous delivery, of course, is also a bit more bigger, because as first, we are getting all the metrics of the application. Now we are checking something about test coverage. We are checking too if the application is releasable finally. And releasable means all the automated tests have to pass through. The metrics have to fit. I have to have a good test coverage. I have to see the complexity is reduced, and so many other things. There, for this reason, I need to have a feedback cycle. This information have to be available almost for the whole team, that they can see, okay, the things I was implementing, they are working fine. They are in a good quality state. For this reason, I'm define continuous delivery more in a QA stage. Of course, after I have there integrated everything together as an application, I want to deploy it somewhere in a production. Of course, is the last step, but before, of course, full automated in test environments, where we come into something like nightly deploy. If you have a web application, yeah, you have to think about it. No, this web application is not just you are able to create a binary package. You have to deploy it to a server and see the server is coming up. Because if you have some configuration problems, so many times the server wants to start. This is an issue you have to fix immediately. For this, we have this continuous deployment idea to use that. And the strategy behind the scripts we're using should be the same than later are used in production. To not create for every stage something separately. And then we come in this purpose to say, yeah, we really can rerun the things as often as possible to get to know, to get to know what is there, the issue. So we can reconsider continuous integration is keep everything compilable. Continuous delivery is keep it releasable, that you really have an application together and everything is working fine, and then continuous deployment to install. And when you install, you should not have a full automated process to switch or to move everything from the code base immediately to production. There should be a manual trigger. The process itself should be automated, but don't run through completely automated. There should be somewhere a decision to say, okay, now we are in a good state. Now we want to have it in production. There we are arriving this kind of idea. Fail fast. Continuous workflows are just having finally the possibility to see when there is problems. And these problems we can detect when we are execute the scripts, the automation as much as possible, when it makes sense. When this don't work, then we get a failure. And that means we don't deliver all this information to everybody every time, because this is like spam. And when we are reaching the spam, now, well, then it's also not so nice, because, I mean, finally the people, they start to ignore all these emails. They move them in a special folder, and as long you are not giving them a phone call or something, they will not taking attention anymore about this. So when I was working in projects, my first thing I did every day is turning on my computer, and then I connect with the build server or CI server, automation server, however you want to call that, to see if all the builds, even the ones they was programmed for the night, if they was passing through, including deployments. And when then there everything was green, I also was rechecked that the staging systems was available. Not just if I reached the server, I was trying to log in the application to see, okay, so I have a minimum integration test that the application is well deployed and I can use that somehow. And this is very important. And in the case I find some mistakes, then I was able to take the phone and investigate around what happened, to call the correct persons. In the case there was missing a file that is not compiling, I was choosing a developer or investigate the developer was responsible for this problem, or if there was some issues with deployment. Of course, you was talking then with somebody from operations. You have to investigate together with an administrator to check the log files, what happened there, and how to fix this issue. In this way, it's also included when you have to make changes in the infrastructure. This have to be automated processes. You already start them on the development side to pass through. If you have an application server, you need to install a patch in the application server. You do it as first in the test environment, automated. Not you copy something around, and everything have to be under configuration management. And then you are secure that this kind of changes are able to roll out to every station or to every stage. There I need to reconsider a little the word continuous integration, because I often have this discussion in commercial development teams. The commit stage, source control management, Git, is not a quality gate. Absolutely not. This is a tool for team collaboration. Git have nothing to do with software quality. And all these ideas of pull requests, they are not new. We was having this around 2000 with a tool called IBM Synergy, and the ones with the age and the experience to had seen Synergy in life, they will not follow into these ideas of pull requests. Pull requests are very, very powerful in open source projects, but not in commercial projects with full-time developers. They know each other. There you should not, because this becomes a bottleneck. There is no really quality checks, because the problem is finally you have a bunch of commits. Somebody have to check these commits and understand what is there done to make the approval that the commits are moving into the code base. And finally, this person, what is doing? Compile, and everything passed through. Yeah, he is merging. This is time and money consuming, finally. And for that reason, I'm not a fan of this pull request strategy. I'm absolutely not. To reach quality, we have there other strategies. We need to applicate now and then use this continuous delivery and continuous integration purposes. As first, see that everything is compilable, and then get your matrix. Check very often the test coverage, how well your code is covered. So many other information. The matrix there helps you a lot about finding out qualities. And in Java, we have there so many tools, spotbox, PMD, check style. We can applicate, we can create with this a lot of reports to keep the quality. And there's other tools like SonarCube you can applicate too. There you reach quality. And of course, to keep more quality, you can do refactorings, you can do so many other possibilities, but not pull requests. Absolutely not. Another problem is, of course, how to manage resources. Sometimes I have the discussion with team members that when I say, okay, we are making, we trigger a build every 1 hour, checking if there is a commit, and then we build. They often say, no, I want to see after every commit, but sometimes commits are very small. Could be a little change, and it's not necessary to run that every 5 minutes, and you have to see a little the frequency also, how often you have there changes in the code base and of how many different people. So to trigger a build, you have to decide a bit, and also one important thing is how long it takes. I mean, when I was there in this time of monoliths, when the build already need 1 or 2 hours to get done, I will not start that every 5 minutes. If I have a little web service that needs, including testing, 3 minutes to compile, well, there is no issue to run that every hour. You can do that often. So always put a little sense into the things you are going to do. Another thing sometimes happen is there's a discussion, yeah, we are not doing any more nightly builds, of course. No. Yes, when there was a time 20 years ago that monolith was taking there 4 or 5 hours to compile, I was not doing this during the day. I was doing this in the night. But these issues we don't have anymore. Today, when we are talking about nightly builds, we finally mean nightly deploy, and this is something essential. We need it. If we are working with web application, we really should every night deploy our application and see if this server is coming up, because there is a little issue with the configuration file. Well, the server won't start, and especially these issues with configuration. This is very, very hard to discover. When then you have the strategy of fail fast, you may remind what you was doing the day before, why the deployment is not now working, because you was making some changes in the web XML. You forget to close the tag as write or whatever. No? In this way, then you have a good reason to deploy really every night the whole application. And this is finally a full integration test too. Another very, very important thing I'd like to mention is the word release candidate. I really, really have there some issues. I don't like that. One thing is I already explained what I'm understanding about a release. So I have a sprint, and when the implementation of the sprint is done, the result is a release, finally. And this release get installed into a repository server to use it for other things. When I'm working agile and I have there, let's say, a sprint for 1 week. In 1 week, usually I don't have that much new functionality that I want to roll out to the customers, the software. May I collect them for 5 sprints? And then after 5 sprints, I reach amount of functionality I really want to introduce to my customers. And then, of course, I have something we are really mean like this release, but we should call it more clearly production candidate. That means we create for every sprint a release. And if you're not feeling happy with this idea of always incrementing 1.1, 1.2 for every sprint, then keep it like 1.1 minus milestone 1. Put this label of milestones for each sprint, 1 milestone. And then when you reach the production candidate, then you call it really like 1.1.0. Then it's more clear what you're going to do. Because you don't need to treat every release you will not bring into the production like a production candidate. No, they have to do with the testing, retest. You need to scale where you run the bug fixes. If you need to rerun there's something, if you need to bring a new patch or fix somehow because the current release is not installable. So this process is much more easy if you have clear in mind that a release candidate is not really a release candidate. It means mostly production candidate, because we release after each sprint. This shows us something now. is widely famous in the software industry, you know, Melvin E. Conway, the Conway's Law. What finally is saying that every organization is creating his design following by the how to say following by the communication structure. And exactly this is the thing. They have often overwhelmed complex processes. They are not really working for software development. The thing is here, really, when you are aware of that, you could redefine, you could remodel your process, simplify them, the transformation into a way to follow back a standard. If you want to create a release pipeline, then check out the standard. What is the release, like I was explaining now, and how to move that. And then you have a starting point, the current complex process, and you have the goal to make it as easy as possible. And this is workable, because you will not find any tool is fixing your wrong design processes. You cannot change there and say, okay, now I need another tool, and then everything goes fine. No, you have to refactor your process, and then maybe the things goes fine. The same is with architecture. Sometimes there are people are saying, we need orchestrated build because there is something, but no. When you need an orchestrated build, you have a very high issue with your architecture. Check it, what happened there. Mostly there is some dependencies you should decouple, because finally your architecture should help you to find a good way how to orientate yourself in the project. This is done by structures, this is done by conventions, and so many other things. They come together, and you have to take care with projects they are running for 10 years or longer, that the architecture is not gonna to get eroded and to become a ball of mud. And of course, this is normal when you are in a way like to bring out and roll out as fast as possible new features, because the business is needed. You have a high competition in the market. But there is coming a point where you say, okay, now was developing a lot of features. Now we have to make an audit to see if the architecture still is that what we was planning in the beginning, to bring that back. And if you see there is something like orchestrated builds, then you have a hint to check what is the problem, maybe. And this you can find also in the very nice book of Robert C. Martin, Clean Architecture. He is mentioned there in this book so many topics of this problem, because if the architecture is not working, you will not fix this problem with a tool. And there we are coming back to the statement of Gotti Book. A fool with a tool is still a fool. So fix do your homework, fix the things, and exactly then you are able to reduce complexity. With reduced complexity, the things goes more easy. That's all. You don't need to overcome there and put the things more difficult. Don't add more complexity to manage the problems. One of the things we are talking when we are talking about standard is something I really mention as much as possible: semantic versioning. The biggest benefit of semantic versioning is you can see incompatibilities. So the point is, if I have a Mayor version number 1 and I have a Mayor version number 2, I know that 2 is not backwards compatible with 1. What that means, finally, every Mayor AP change is incompatible with the existing code. Then I have to increase the Mayor. Why? Or what it is. Finally, if I remove a class, if I rename a method, if I change there somehow the how it called the parameters, then I have the problem that finally the consumers of my API have to adjust somehow what I deliver there. And when I make there the major change, they see, okay, he is doing there something, and I have to check before I use the new artifact if I have to give there some hands-on that is still working. And there we are also there a bit in this topic now of GitHub, when this is sending you all the time this nice recommendations of depend the bot to update your artifacts is not so easy like it seems in the beginning, because when you have there some API incompatibilities, this tool can getting really your nerves. So for that reason, I was deactivated. Replacing some artifacts is a very big issue. You cannot do that so easily, less in commercial software development. And there is a lot of arguments for that in this book of Jets Humble continuous integration, continuous delivery. And if you don't feel happy, like I say previously, no, with increasing the minor all the time, if I add just functionality, you can use the label and then just place there milestone 1, milestone 2, and then the amount of numbers don't increase that dramatically if you have very short sprints. And another thing, what is very nice in semantic versioning is with a patch level, you get an idea about your quality. Because a patch level, you just applicate in the moment, you have to re-release with patches because there was some really big issues. You needed to deliver the fixes immediately. And if you have a very high number of patch level, there you have an indicator to check, okay, what is the problem? Is not to stress somebody or get wrong with this person's, no, it's just find bottlenecks in your process and in your workflow to increase your productivity. Yeah, with so many things there, with this semantic versioning, no, I can assume a lot of things I can use then in the automation, because this don't help me all the time if I'm going there to waste a lot of resources or rebuild. I was involved in teams. They have there was had for the previous release of their application a team of 5 configuration managers, and for the upcoming release there was a team of 15 configuration managers, and the amount of developers was 20 who was working in the code base. So there you see there was a lot of administrative overhead, and this we need to avoid, because when we are thinking there is, since the 1970s in commercial software projects, 80% until today of commercial projects fail, and that don't mean they are trashing away. Project fail means they are getting more expensive, or they are not getting done in the correct time they are needed to be finished. And this is a fail. We can release some resources. For example, if we are working with tools like Docker, if I do, or if I run a delivery and permanent installation to a stage, I don't have to recreate all the time the image and then instate the container. I can reuse the already created image. But I have to have an automated process to create this image, because sometimes it's necessary to make there some updates, including their patches or whatever. And exactly this is the thing. Redo the things when they are necessary, not because I can. But this costs money. If you are there in these cloud environments of AWS or Google or whatever, and you have there a lot of computing power. It's not for free. You have to pay for that. And finally, first, your company is paying, and after this, the client. So think very wisely how often you want to repeat the things. The last point, of course, I need to give an eye on is a rollback. Often development teams or operational teams, they have the idea, yeah, we are using blue-green deployment, we are having canary releases, and we, in the case of some heavy issues, we are able to make a rollback. Mostly, it is more in the way, okay, when the current deployment don't work, I can keep running the current system, or if the deployment was working and the system crashed very fast, then we have several strategies that everything works fine to roll back. But what happens if I roll out a system and after 3-4 days, because of more users or something, they occur a very heavy problem? Then I am not usually able to roll back so easily. More in the case when I have there some database changes. So this is one of the things they describe in the book, continuous delivery too, where they were saying, okay, I need really for every data migration scripts to migrate forward and backward. And it's not just to having the script, really check that these scripts are really working, because if not, well, then how you are secure? You don't want to find out your script don't work in the moment of the most stressful situation, when the things goes really, really wrong. So for that reason, really take care. If you are thinking to move into DevOps, you really move into this idea of continuous. First, take care you have test automation, a real test automation. Secondly, you have to have strategies in the case of the automated deployment go wrong. What is the problem? So there's some other strategies you can apply too, feature toggles, feature flags now. There you are in a secure path where you explore more and more experiences in this field of continuous something, continuous DevOps, continuous security, continuous data migration. It's a very, very interesting topic. But first, you need to do the homework, simplify your processes that they are able for automation, understand what you want to reach, and give a fast feedback in the case something failed. So yeah, there are some references here I was using in this presentation. In the case there is some questions, feel free to ask me. A lot of thanks for your attention, for joining this talk. I hope I was giving some nice ideas. In the case you want to contact me, you can find contacts in my homepage or write me an email here. Yeah, or on Twitter at Elmer. I'm reachable. Thank you.